Everyone's seen it. That massive stone bridge in southern France that looks way too perfect for something built 2,000 years ago. No steel, no electricity, no modern cranes. Yet it still stands like it was built yesterday. Today on History of Questions, we're answering a deceptively simple question that breaks people's brains every time they hear it. How did the Romans build the Pont du Gard? And trust me, the answer is smarter, crazier, and more impressive than most modern construction projects. To understand how they built it, we first need to understand why it existed at all, because this wasn't about beauty or flexing engineering skills. The Roman city of Nemesis, modern-day Nîmes, was growing fast, and the local spring couldn't supply enough clean water anymore. Roman engineers planned a massive aqueduct system stretching about 50 kilometers to bring water from the Eure spring straight into the city. The Pont du Gard was only one section of that system, but it had to cross a deep river valley, which is where the real challenge began. Here's where Roman engineering goes full brain rot mode. Across that entire 50-kilometer distance, the water dropped only about 17 meters. That is an insanely small slope, barely noticeable to the human eye, but it was enough to keep water flowing smoothly by gravity alone. Too steep and the channel would erode. Too flat and the water would stop completely. Roman surveyors used precision tools like the chorobates to measure tiny elevation changes with shocking accuracy. Quick pause. If ancient engineering like this makes your brain light up, hit subscribe to History of Questions. We answer the kinds of historical questions that schoolbooks skip over, and subscribing helps this channel keep going. Like the video too, because the algorithm only listens when people interact. Now here's the part most people wonder about. Why did they build the aqueduct so high off the ground? The valley of the Gardon River was deep and wide, and dropping the water down and back up again would break the slope completely. The only solution was to lift the channel high above the river while keeping that perfect gradient. That's why the Romans built a three-tiered structure made entirely of arches, which distributed weight outward instead of downward and made the bridge incredibly strong. This is where things get even crazier. Most of the Pont du Gard was built without mortar. The stones were cut so precisely that they locked together under their own weight, like a massive gravity-powered puzzle. Some of those limestone blocks weighed up to 6 tons, yet they fit together so tightly that the structure barely needed binding material. Mortar was mainly used only in the water channel, where waterproofing was critical. So how did they lift stones that heavy without modern machinery? The Romans used treadwheel cranes, which were basically giant wooden wheels that workers walked inside like human engines. As they walked, the wheel turned ropes and pulleys that lifted enormous stone blocks into the air. Combined with ramps and scaffolding, this system allowed them to place stones with terrifying precision. It wasn't brute force, it was physics and teamwork. Another quick pause. If this video is changing how you see ancient history, make sure you're subscribed to History of Questions. Drop a comment too, because I genuinely want to know if you expected the Romans to be this advanced. One of the smartest moves the Romans made was building the structure from both ends at the same time. They constructed the arches outward from each side of the valley and worked toward the center. That saved time, but it also meant that if their calculations were even slightly off, the entire structure would fail when the arches met. Somehow, using geometry, experience, and string lines, they aligned everything perfectly. At the very top of the structure was the spicus, the narrow channel that actually carried the water. It was lined with waterproof mortar made from lime and crushed tiles, which prevented leaks and slowed algae growth. Maintenance workers could walk inside the channel to clean out sediment, showing that the Romans planned for upkeep long after construction. This wasn't temporary infrastructure, it was long-term urban planning. The reason the Pont du Gard still stands today isn't luck. It's because the Romans over-engineered it on purpose. Water supply was a matter of survival, so failure wasn't an option. The combination of high-quality stone, perfect weight distribution, and constant maintenance allowed it to survive floods, wars, and centuries of use, even when later generations repurposed it as a road and toll bridge. What the Pont du Gard really shows us is that Roman power didn't just come from armies. It came from planning, logistics, and engineering knowledge passed down through generations. Thousands of workers were coordinated without modern communication. Materials were sourced locally, and the project was executed with almost unbelievable precision. This was institutional intelligence at work. When we ask how the Romans built the Pont du Gard, we're really asking how humans solved massive problems with limited tools. It proves that innovation starts with understanding fundamentals like gravity, geometry, and materials. 2,000 years ago, those principles carried water across a valley. And honestly, they still shape the world we live in today. So now you know, the Romans built the Pont du Gard with precision, patience, physics, and pure human brainpower. No shortcuts, no magic, just people pushing the limits of what was possible. If this answered your question and sparked a few new ones, make sure you're subscribed to History of Questions, because history gets a lot more interesting when you understand how things were actually done.